एजुकेशनल और टेक्नोलॉजी रिलेटेड वीडियोस के लिए सब्सक्राइब कीजिए और बेल आइकॉन को दबाइए।
Hello friends, I am Sadashi Takre and you are watching Knowledge Planet. Today we are going to discuss about acid, basis and salt. This is the second part of video. In the first part we have learned about what is acid, what is basis and Arrhenius theory of acid and basis. So let's start the second part of this video. Basicity and acidity of acid and basis. Friends, complete the following table. In this table we have to identify the number of H plus ion and number of OH minus in each molecules. In the first row, the acids are there, so the number of H plus obtained from one molecule. HCl, from HCl, only H plus, one H plus is obtained. In HNO3, one H plus is obtained. So we have to write only the number of H plus, how many number of H plus are present in that particular molecules. As the same case, in the case of base, how many number of OH minus molecules are obtained in that OH minus ions obtained in that molecules. Let's see, in the acid, in the HCl 1, HNO3 1, H2SO4 2 H plus ions, H2CO3 2 H plus ions. As the same in the acetic acid 1 H plus ions is there. And like same in the case of base, number of, we have to calculate the number of, or we have to identify the number of OH minus. So in NaOH, one OH minus is there. In KOH, one minus OH is there. OH minus is there. As like same in AlOH3, three OH minus are there. FeOH taken thrice, three OH minus are there. So on this table, we can say that the basicity of acid means the number of H plus ions obtained by dissociation of one molecule of an acid is called as basicity. As like same way, acidity of base, the number of OH minus ions obtained by the dissociation of one molecule of base is called as acidity. Means in the other hand, or in simple word, the acidity of base is nothing but the how many number of OH minus present in that molecule, and the basicity of acid means how many number of H plus ions in that molecule present. So that is simple. So we can again say acid and bases are also classified according to their the basicity and acidity. And like friends, tell me one thing, on the basis of above table, give the example of monobasic, dibasic and tribasic acids. So identify, it is very simple. Monobasic means, which are the mono examples of monobasic? HCl, HNO3 and acetic acid are the examples of monobasic acids. In the dibasic, H2SO4 and H2CO3 is the example of dibasic. And the same in the tribasic acids are H3BO3, H3PO4. These are the tribasic acids. And like same way, we can say monoacidic, diacidic and triacidic base. Okay friends, get it? Now next, concentration of acids and bases. Let's see one example. Cut the lemon into two equal parts. Take a juice of each part into two separate beakers. In that two separate beakers, in first means pure 10 ml of drinking water in beaker A and 20 ml water in beaker B. In these beakers, the quantity of lemon juice is the same, but what is the difference? Their tastes are different, and the solution of the first beaker is more sour than the second. What? In the first beaker we have added only 10 ml water, but in the second beaker, in beaker B, we have added 20 ml of water. But the lemon juice quantity, means the quantity of solute, is the same, but the taste is different. Why? Although the quantity of solute is the same in both solution, but the quantity of solvent is different. Solute means lemon juice is a solute, and solvent means water, which is we have added 10 ml and 20 ml. These are the solvents. So solvent is, well, the quantity of solvent is different, but the solute is same. So what happen? The ratio of the quantity of solute and solvent is different. So the ratio of quantity of solute to the quantity of resulting solution is the different. Understand? All the properties of solution depend upon the nature of solute and solvent, and also the proportion of solute and solvent. In beaker 1, the proportion of solute and solvent, only 10 ml solvent is added, but in the beaker B, solute is the same quantity, but solvent is increases by 10 ml. So the proportion is different. That's why taste is different. That's why solution is different. Now, the proportion of solute in a solution is called as concentration. What is concentration? The proportion of solute in the solution is called as concentration of solute in the solution. When the concentration of solute in its solution is high, means it is a concentrated solution. So A is a concentrated solution because the solute is high in that solution, while the solution is called dilute solution when the concentration of solute is low. In the beaker A, only solvent is 10 ml, but in beaker B, solvent is 20 ml. So the solute quantity is more in 10 ml, while in 20 ml is less. That's why A is a concentrated and B is a dilute solution. So concentration can be expressed by several units. Two of these units are usually used more frequently. The first is gram per liter means G upon L, we can say, and the second unit is molar, or that is molarity. So molarity is nothing but the number of moles of the solute in dissolved in 1 liter of solution. It's called as molarity. The molarity of solute indicates that by writing molecular formula inside the square bracket. Means, for example, NaCl. So NaCl should be written in the bracket equal to 1 means 1 molar solution. So friends, now complete the following table of the concentration to get exactly idea about the molarity and gram per mole solutions. See this table. In this table, we have to observe this table. In the first example, sodium chloride, the molecular formula of sodium chloride is NaCl. Molecular mass is 58.5, and gram, how many grams are used? NaCl solute 117 gram is taken. So how many moles? Moles is calculated by gram upon molecular weight, 2 mole. That's why volume taken, volume of solution 2 liter. So the concentration of solution in gram per liter will be 58.5 gram per liter, and in molarity 1 molar can be calculated by the using above formulas. Same we have to calculate HCl and NaOH. HCl means name of the HCl. What is the name? Hydrochloric acid. So molecular mass of HCl 36.46. How many quantity of solute taken? 3.65 taken. So what will be the mole by calculating D upon C? So what will be 0.1 mole. Volume of solution 1 liter. So what will be the concentration in gram per liter? Definitely 3.65 gram per liter. And what will be the molarity? 0.1 molarity. And like same, NaOH means sodium hydroxide. Molecular weight 39.98. In gram 59.98 gram, 1.5 mole in 2 liter. Then what will be the concentration? 29.99 gram per liter. And what will be the molarity? 0.75 molarity. So friends, on this we can exactly calculate